Descriptive statistics, page 7 and 8. Number 2. The table shows the petrol sales in one day by a number of city service stations. How many service stations were involved in the survey? What they want here is the total of this column. Estimate the total number of petrol sold for the day by the service stations, and find the approximate mean sales of petrol for the day. Okay, so I guess like each one of these frequencies, each count is a day that was measured. And so if a day sold between 2,000 and 3,000 liters, it would be here. If a day sold between 5,000 and 6,000 liters, it would be here, etc. Okay, so first step is to figure out how many days total. And the easiest way to do that is with the calculator, or just add them up in your head. They're not that hard, right? But since we're going to need to put this data in here anyway, I'm going to go ahead and put it in here. So I'm going to do stat edit. And I'm going to use list 1 and list 2. So I'm going to clear the lists by pressing clear while on top of the list name. And so list 2 is going to be the frequencies, and I'm going to put those here for 9, 14, 23, and 16. And what do we put in the first column? It's like we talked about this in class, but when you have an interval like 2,000 to 3,000, what do you put here? You can only put one number. Do you put 2,000? Do you put 3,000? Actually, what you're going to put is the midpoint of the interval, because that is kind of like a halfway point between the two extremes. It's kind of the average of the two, the minimum and the maximum. So it's a guess as to the typical value that's found in this interval, although of course it's not going to be right. It's an estimate. Okay, so instead of putting 2,000 or 3,000, I put 2,500. The next one's going to be 3,500, etc. And I'm going to pause while I enter these because it's really boring to watch. Okay, I finished putting in the midpoints of the liters and all my frequencies, and now I'm going to find all sorts of information about this table with stat calc 1var stats. And I'm going to put list 1, which is second one. I'm going to put list 2 in for the frequency list and press calculate. And I get all sorts of data. And I'm going to write some of this down because I think I'm going to use some of it later. I'm going to put that x bar equals 5871. And I want to know the total of these frequencies. Let's see if one of those is the total of the frequencies. There it is. N equals 70. That means there are 70 samples here. So actually the total is going to be 70. And let's see, estimate the total number of petrol sold for the day by the service stations and find the approximate mean sales of petrol for the day. So the mean sales of petrol for the day would be X bar. Okay, so that would be the answer for C. And B, estimate the total number of petrol sold for the day by the service stations. So the total would be all of these values added up before you average them. So that would be like the summation of all the data. So it would be like sigma x. So that would be this here. So C or B would be 411,000. Okay, and this of course would be A. The total would be 70. Okay, moving on to number 3. This frequency histogram illustrates the results of an aptitude test given to a group of people seeking positions in a company. First question, how many people sat for the test? And so the same thing again, we need to figure out the total number of people counted here. Since it's not a graph, we just need to go through and assign values or frequency quantities to each one of these and then add it up at the end. So I'll do that offline. Hold on a second. First thing I did was I said how many people are in each one of these bars. So it's 5, 10, 25, 40, 10, 15, 10, 10. Then I entered them into a column here to represent the frequency data, and then I took the midpoints of each one of these intervals to represent the data, so 85, 95, 105, etc. I put those in columns L3 and L4, and now I'm going to find out some statistical information about it by putting L3 and L4 into list and frequency list and pressing calculate. And then I'm going to write down some of these important numbers, like, for example, X bar. We usually always need X bar, 119, and N equals 125. Now, the first thing they asked us was how many people sat for the test, and that, of course, is 125. Okay. Estimate the mean score for the test. Okay, that would be 119. Then it says, what fraction of the people scored less than 100 for the test? So less than 100, we have 5 people plus 10 people. That's less than 100. So that would be 15 out of 125. 15 out of 125, which is equal to, and here I'll just do this calculation real quick with an online calculator. 12%. I got 0.12 out, and I'm going to change that to 12%. What percentage of people scored more than 130? More than 130, that would be 15 plus 10 plus 10, which would be 35, also divided by a total number of people, 125. So let's figure what that would be out. One calculator, 28%. Okay, that's it for number 3. Not too bad, right? 20C. Measure the spread of data. On page 517 reading, these are the two different statistics measuring spread or dispersion. That's another way of saying spread, a more technical way of saying spread. One of them is range, which is the maximum value minus the minimum value. That's the one you've been using since about 6th grade. See example 6 on page 518. We're going to talk about IQR, which is the interquartile range. Interquartile range. Oops. Okay, interquartile range. Interquartile range is the, if you have 100 people, you would take the 25th person and the 75th person after you put all the samples in order, and then you would subtract them from each other. That would be the interquartile range. What's the difference between interquartile range and range? Well, in range, you take the first person and the 100th person, and you take their difference. In interquartile range, you're taking the 25th and the 75th person, so you're kind of taking the middle half of the people and finding the range of that. Why would you do that instead of finding the range? Well, the range, since you're taking the maximum and the minimum, you got some extreme values there, like the top guy and the bottom guy. Maybe they're like especially good or especially bad. So maybe it'll throw off your dispersion measure if you only look at those guys. But if you discard the top 25 guys, you discard the bottom 25 guys, then you're kind of really looking at the center results, which are a little bit more stable. So that's why you might do that. Okay. For each of the following data sets, make sure that the data is ordered, and then find the median, the range, the upper and lower quartiles, also known as Q1, which is the lower quartile, and Q3, which is the upper quartile, and the interquartile range. Okay, so we're going to take this data here, and the first thing we're going to do is we're going to try to put it in order. And so let's see, 10, and then we'll try to take, let's see, 12. That looks like the next highest thing. 12, 12. Then what's the next highest one? Maybe 15s or 14. Maybe the next highest one, 14. Then we got 15, 15. We got two 15s. We got 116. We got 117. How many 18s we got? 1, 2, 3, 4. 3 18s. And look, I missed a 16. Where is this? 16. And let's see. Okay, now we got some 20s, right? Oh, I got 19. Okay, then I got a 120, a 21, and a 22. 20, 21, 22, and last of all we got 24. So I put those in order first. And then I just noticed that I've forgotten a fourth 18th. There's 4 18s, right? 1, 2, 3, 4. So I put another one there. Okay, and so I'm going to do this one by hand so that you can see how you do it by hand. First of all, we're going to look at the range because that's the easiest thing. So we're going to take the minimum, which is 10, the maximum, which is 24. We're going to get the difference between the two, which is 14. All right, and then for the median, what we're going to do is we're going to say, okay, there's 18 total numbers. We're going to find the 9th number, the 10th number, which are in the middle, and we're going to take halfway in between there. So we'll say 1, 2, 3, 4, 5, 6, 7, 8. 9th number is 17. 10th number is 18. Halfway between those two is 17.5, so that'll be our median. Then the upper and lower quartiles. The upper and lower quartiles would be Q1 and Q3. The lower quartile would be the number that's halfway between the first and the 9th number, so maybe the 5th number. So 1, 2, 3, 4, 5, it would be 15. And then the upper quartile would be halfway between the 18 and the 24, so maybe the 5th number here, 1, 2, 3, 4, 5, which would be 19. Would be the upper quartile. And then the interquartile range would be the difference between those two, so 19 minus 15 equals 4. Okay, and that's it for that one. You can do this on the calculator also. Here you can see that I have put in stat edit into L5 and L6. I put the data, 10, 12, 14, 15, 16, etc. Then I put the quantities, the frequencies for each one, 1, 2, 1, 2, 2, 1, 4, etc. And then I ran stat calc 1-bar stats, and I can get all the same values that I did by hand. So for example, the total number of frequencies is 18, the minimum value is 10, Q1 is 15, Q3 is 19, the median is 17.5. So the IQR would be 19 minus 15. Okay, I don't think they have IQR here. You just calculate it from Q3 and Q1. Okay, and that's it for this page. Let's move on to page 8. The time spent in minutes by 20 people waiting in a queue at a bank for a teller were, okay, find the median waiting time and the upper and lower quartiles. Okay, so the easiest way to do this, again, is with the calculator. So you do stat, edit, and I'm going to put all these numbers in the calculator. And I think I'm just going to put in the list without doing a frequency table because, I don't know, it would be too hard to go through in here and figure out all the repetitions. So I'm going to go ahead and just put them in like that. Hold on while I do that. So I just went through and typed all these into list 1, and now I'm going to do a stat calc 1-bar stats with list 1 as data, or the list, and then I'm going to clear out the frequency list because there is no frequency list. And then I got some answers here. Find the median waiting time and the upper and lower quartiles. Okay, so I'm going to put those in here. I'm going to put first Q1. Well, I'm just going to kind of put them in order so I don't have very much space to write. So 1.45, median is 2.45. And the Q3 is 3.8. Okay. Find the range and the interquartile range for the waiting time. So the range would be minimum minus maximum. So it would be 5.2 minus 0. So it would be 5.2 would be the range. And the IQR would be 3.8 minus 1.45, which would, I'm going to do that on an offline calculator. 1.45, 2.35. So, of course, the IQR is less than the range. Copy and complete the following statements. 50% of the waiting times were greater than so-and-so minutes. So that would be 50% of the waiting times would be greater than the median, right? So the median would be 2.45. So we'll put 2.45 for this one. 75% of the waiting times were less than or equal to, okay, so just to give you a little picture here, we're going to say, okay, minimum, and then we're going to put Q1, median, Q3, and maximum. And so each one of these sections has 25% of the people in them. Okay? So when they say 75% of the waiting times were less than or equal to a certain number of minutes, they're talking about this part here. So that would be the number of people that were to the left of Q3. To make things easier, I've transferred all the answers up here down here. So the number of people to the left of Q3 would be the number of people who waited less than 3.8 minutes. Okay, and then the next question says the minimum waiting time was 0, the maximum waiting time was 5.2, and the waiting times were spread over 5.2 minus 0, which is 5.2 minutes. Okay, moving on to the next one, last one. The heights of 20 10-year-olds were recorded in centimeters as follows. Find the median height and the upper-lower quartiles of the data. So once again, I think the easiest thing is to just type this list of numbers into the calculator. One thing it seems like they did to make it easier for us here is they did put the data in order. So I could maybe like enter it as a frequency table if I group the data like this, right? So I'm going to go ahead and type these numbers in, and I'll be back in a second. Okay, so I've entered our data here in L2 and L3, so I put in all the data, the heights, and then any of the heights that had two people with the same height, I put a 2 instead of a 1, and then I did not repeat the numbers like they are here. I put like 114 times 2 instead of 114, 114. And then when I do stat calc, then I have to make sure when I do one-bar stats that I put the frequency list here, L3, and then I press enter. And we're going to make up the same kind of chart that we did last time. We're going to mark minimum, Q1, median, Q3, and maximum. So let's go down and see those. Minimum is 109, Q1 116, median 124, next number is 130, and the maximum is 138, and the total number of people is 20. N equals 20. And then let's look at the questions. It says, find the median height. So the median height would be 124. Upper and lower quartiles would be 116 and 130. Right? This is Q1, this is Q3, this is the median, this is min, this is max. Complete the following statements. Half of the children are no more than, so that means half of the children are no more than, it means less than this amount. It would be 124, the median. 75% of the children are no more than, and so that would be referring to 3/4 of the children would be less than 130. Find the range. So the range would be the max minus the minimum, so 138 minus 109. It would be 29. The interquartile range would be Q3 minus Q1, so 130 minus 116, 14. And then the middle 50% of the children have heights spread over, and so that would be the same as saying the IQR, so it would be 14. Okay, and that was the last one for this section.